How you doing there, big boy Chris? My sister dared me to say that. I don't know why. She's having a cracker. But anyhow, I've just got back home after my 4-night bender. I'm so sorry for being like not doing anything. But now that I'm back, you know, a little bit of a devlog. I think I should show what I have been working on. So I'm gonna have to make this into 2 videos and stitch them together, which is gonna be annoying because of the screen recording software I'm using. But that's alright. So I'll be able to record essentially what's going on in Unity in a moment. So basically what I've added functionality for is for you to be able to find the neighbor tiles. So I press start. Yep. So this is a good little example. Let's just go to the map spawner. So essentially I've created a script that you can pass through. I'll zoom the camera out as well, actually. Just make it a little bit easier for the view. There we go. So essentially made a script that you can pass through a transform position, a radius, which is an integer, and a boolean whether you want to have skips or not. And I'll show you what they do. So these are some little temporary variables that I'm just running through a draw gizmos. So it's just a draw gizmos, and it's just printing out these little spheres at every single hex, essentially at every single hex position. Sorry about the background noise, by the way, Chris. But anyhow, I'm going to put in a position. So where's a better position? Yeah, there we go. So and I'll just change this radius to 0. So we're going to play around with the hex at position -4, 1, and that's the position. Sorry, the position that's actually stored on the grid, essentially. So that's at that position. We can change the radius, so we might want to find the hexes within a one block radius, or one distant radius. And as you can see, it's just printing off a sphere on every single hex in that thing. The other thing is this allow skips. Obviously here you won't notice the difference, but if I start to increase it, you can see that it's essentially 1 by 1 as the radius increases. It's creeping up sort of this little path to the right. But if let's make it smaller, so it's just made it through. If I turn on allow skips, it'll actually be able to skip this point, and as I decrease it, you can just see it's like just coming out like an actual radius. So this is the reason why I had to code it really weirdly, because I actually wanted it to be able to essentially store null hexes. So this actual whole system doesn't actually use hexes. It actually uses essentially an array of vector 2 ints. So I can actually store the actual invisible tiles. Well, actually, everything's stored as a vector 2 int. And then I go through a dictionary and I pull all the hexes within that I pull all the hexes. Sorry, so I've got a dictionary of vector 2 int as the key to actual hexes, and for every single vector 2 that I've actually found, I get the actual hex tile for that. And the difference between allow skips and not allowing skips, so increase the radius, is that I make sure that the key exists before I actually throw the vector 2 into the array or into the list of vector 2s. But if I got allow skips off, if I got allow skips on, it'll add every single vector 2 no matter what. If I got allow skips off, it'll only add those vector 2s if I give it permission to do that. Like if it actually exists as if the key is contained within the actual dictionary. So I'm going to pop over to the code side and sort of show you what's going on. Welcome, Chris, to the coding side of things. Big boy Chris. Oh damn it, I didn't get a laugh out of my sister that time. Anyhow, Yeah, so this is the coding side of things. Here you can see that here's the integer, the position, which is actually an origin. I think origin's a better point, which is the origin position, which is the point where you're looking from to find the neighbours from. And then there's the allow skips bool. They're all the I don't know, variables that the onDraw gizmos function uses to draw those little spheres at the hexes transform positions, which is pretty cool. Anyhow, yeah, here's the dictionary, vector2 to hexes, which I called a current spawn map. If I find it here in the map spawner script, should be grid finder. Yeah, here we go. Grid finder about the instance, and it sends across the map reference, which is, I think it's a dictionary that it makes. Map reference. Yeah, cool. So yeah, I've got a little dictionary called map reference. And every time I create a hex, I just add it to the map reference, passing in the hex itself and its vector2 int, which is stored in the actual level itself. So let's go map reference. Yeah, there we go. Add the element at the element.grid position. So an element is just map element. It's kind of weird. A map element holds a hex. So a level's made out of map elements, which have a vector2 int for its position plus the actual hex itself. So I'm just passing through the element at a given level and the hex instance, which is a hex actually found at that point. So I'm actually finding a real. So I'm getting essentially the levels. Levels position, so the levels, like the hex's level position, and I'm also passing across the actual, instead of a reference to the levels hex, I'm actually passing a reference to the actual instantiation of that particular hex. So that's pretty cool. Anyhow, so essentially, yeah, it just, once it's all done that, it just goes grid find it, instantiate, set map. It just passes in the map reference, which will go to that function, and yeah, that set map just sets up the current spawn map, which is pretty much what this grid finder uses to make all of its calculations. Cool. Get all neighbor hexes. Oh, let's go to get all neighbor points first, actually. So we'll get all neighbor points. So as I said, the way I've coded this, it actually gets vector2s, or list of an array of vector2s, and then obviously public get all neighbor hexes gets the target points, which are the vector2s, and it converts those target points into hexes. So if a hex is actually found at that location, cool, it'll be added to the if current map contains a key at that point. So if that vector2 exists in the dictionary, in other words, there actually is a hex at that point, we will add that to the current spawn map array. Yeah, if that makes any sense. So yeah. Sorry, adds it to the neighbor hexes array, which is what it returns. Cool. So this function just essentially returns all the neighbor hexes at an origin point with a radius, which I don't know why I'm calling a radius. Is it technically a radius? It's like a distance between hexes. I don't know, radius will do for the time being. And we've got a boolean whether we want to move over gaps, which we actually do pass into the vector2 and target points, which again I'll explain here. Cool. Come back to here, same stuff, move over gaps. Don't really need to worry about that equals false. It's just like if actually, are you familiar with having like an equal something in a what do you call it, in the parameters. It just means basically I can just go get all neighbor points, and I could, yeah, like it'll automatically make it false. So I could just put in vector2, vector2 int 0, put 1, and I can just close that off, and it'll automatically make it equal false. However, I can just make it equal true if I wanted. It's pretty cool little system. I don't know if you said you knew what that means, Chris, but anyhow, there you go. So that's what that's about. Probably pretty obvious. This is kind of confusing because I've created a bunch of lists. I've got an N for found points. So neighbor, and N just stands for neighbors. So these are the points that the neighbors have actually been found for, and the new points are the points that we need to find the neighbors for. It just goes through, essentially goes out as the radius increases, and it just I've got another list here of new points and old points. Oh yeah, and they're called new points and old new points. It's just it's some pretty messy coding. I probably could clean this up, but it's if you have a little look through, you can pretty clearly just see what it does. It's just for each point and getting surrounding neighbor points, which is another function that I made. Yeah, it just plays around with that. I think I'll actually, probably the next thing to show off is the get surrounding neighbor points. Getting surrounding neighbor points just returns another vector2 int array, and it just finds the neighbor points in the immediate area from that particular vector2 int. So I got the origin, then return empty positions. So yeah, essentially, if empty position hex is false, position is false, it won't return empty positions. It's pretty simple, but that means like, oh yeah, this is like the rules. Like it'll look for a hex at its position plus 0 and its position plus y equals 1. If yeah, these are all for when, because it's a hex grid. Depending on if y is even or odd, it'll actually have to look for different things because hex grids are annoying. Actually took me a while to figure out the exact positions because I could have decided to create a flat top grid, which everyone that uses Unity decides to create a pointed top grid. So I had to just, you know, with trial and error, actually find these particular positions. Again, I'm an idiot. That would have been such a more simplistic way of finding it, but who cares? These are basically the rules to see if yeah, cool, there is a hex there. We'll allow you to return an actual hex. So if allow equals true, essentially goes and adds the new neighbor position. However, this is where this return empty positions ball comes into play, which is set by this move over gaps boolean. So essentially, if we want to return empty positions, it'll just go, oh, I don't really care. I'm just going to return any position. I don't care. Just pass up any position, even if it's essentially an area where there's no hex. It'll return that position. However, if that is actually not the case, we're only going to return the positions if the key is contained in the dictionary of the current map dictionary. In other words, this will prevent it from you know, using to skip a gap, you know, but this will. And anyhow, that's pretty much how this get all the neighbor points function works. It just gets a whole bunch of vector2 neighbors, vector2 int neighbors. So it's not hex neighbors. It's essentially an array of vector2 ints. Again, this get neighbor hex functions uses this a vector2 int, and it turns that all those vector2 ints, those target points, into an actual array of hexes. Essentially, so yeah, pretty simple stuff. Yeah, and it just checks if the current map contains a key. So if once it goes through all those vector2 ints, so obviously the original vector2 array of vector2s, sorry, oh my god, I'm an idiot. The original vector2 array might contain null hexes in it. So essentially, it just does a check if it contains contains a point, and if it doesn't exist, if it does exist, then we'll add that to the actual hex array. Essentially, pretty simple stuff. Is there anything else to show? Oh yeah, this is just the functionality for actually getting a hex at a particular point. It just passes a vector2 int, or by overload, we can just put an x and a y position, and it just uses that. Just uses the current spawn map, passes in that vector2 int as the key, and it just gets a nice little hex. Pretty simple stuff. And then here's the onDraw gizmo. So if current map does not equal null, this is just to make sure that the map's actually been instantiated by the map spawner, which sets it up again. If it is the case and the current map key count is greater than 0, I don't know if, yeah, just to make sure it actually exists. Then we just start spawning in a bunch of spheres at each hex in the test neighbors array, which essentially just uses that temporary grid, the temporary radius, and the temporary allow_skip spool that we've created. The variables have been created right here. Template is used by the gizmo stinger, and it just just creates a sphere at all the transform positions that it finds in those test neighbors. Too easy, quite simple, and Bob's your uncle. So yeah, I think that's all I've got to show you, man. Thank you.